Standard 8 Maths Chapter 8 Comparing Quantities. Hello everyone. In last video we have seen some example of compound interest. Now in this video we will see how this compound interest can be applicable to, or what are the applications of this compound interest in calculating see increase and decrease of population, or increase and decrease of any parameter. We can say it can be population or it can be price of an articles or so on. So we will see with the example. So example 14, it is example 14. What they have said: the population of a city was 20,000 in year 1997. It increases at a rate of 5% per annum. Find the population at the end of 2000. Okay. So it is simple, like the case of simple interest or compound interest question. So initial population was 20,000. Rate of increase was 5%, and his population was 1997. So we have to time period is 3 years. We have to calculate at the end of 2000. Okay. So rate time period will be 3 years. Now for first year, like we calculated simple compound interest stepwise, it will be the same. So for first year population at the end of first year, that means at the end of this 1998, in 1998 population will become, to final population will be this 20,000 plus 5% increase. If it has stated that it is a decrease in 5%, so this will be minus. Since it is increase, so we are adding 5% of this 20,000. Okay. So this is, so it is 21,000 at the end of first year. Now, like in case of compound interest, what we used to do, amount of first year will be treated as principal for second year. It is same in this case. This population of the end of 1 year will be treated as principal, or the population for second year. For second year, final population will be, that means at the end of 1999, final population will be this 21,000 plus, again it has been increasing 5%. So this is 21,000 plus, okay, so it comes out to be 22,050. So at the end of second year, population is this much. Okay, it is almost similar to compounders. Now what happens in third year, or at the end of 2000? Third year, it will be, final population will be, this is at the end of 2000. Okay, final population will be this 22050 plus, further there is increase of 5%. So this will be 22050 plus, this is, okay, so this will be 231 5 2.5. Okay, so estimated population, we can take the round of value, it will be 23153. So this will be the population at the end of 3 years. So we have calculated stepwise. Okay, or there is one generalized form. So what is the generalized form? That is final value. It can be population, it can be price of a commodity, it can be anything. We have been given some initial value or we have to calculate, and that has been increasing or decreasing at certain rate, and time period will be given. So okay, so that will be final value will be initial value into 1 plus r upon 100 plus or minus, I am explaining, to the power n. See, this is plus, it will be case of if the thing is increasing, okay, and minus will be in case of if the thing is decreasing, and this is n is number of years. So I hope this is clear. Now one more example. A TV has been bought at a price of rupees 21,000. After 1 year, the value of TV is depreciated. Depreciated means it is increased by 5%. Find the value of TV after 1 year. So I will show how to calculate directly here. It is example 15. So what they said, initial value, initial price is rupees 21, this much. Rate of depreciation, depreciation means there is a decrease. Depreciation is 5%. Time period is 1 year. So it can be calculated either way because number of years is not so many, it is just one. So we have to calculate its final price. So final price will be, or final value will be, this initial value minus 5% decrease on this value, that is, so this is 21000 minus 0.5. Clear? So this will be the final price of TV. Or if we have to calculate directly by the formula, it will be, I have explained, final value will always be equal to initial value into 1 minus, because rate is depreciating or rate is decreasing, to the power n. Initial value was 21000, that is 21,000. Rate is 5% and n value is this. So it is 1 upon 20. We calculate it is 19 upon 20. It is 1050 and value comes out to be, so value is same as we have calculated stepwise. Okay. So we will take few more examples. So machinery worth 10,500 is depreciated by 5%, find its value after 1 year. So we will calculate by formula. So its initial value is rupees 10,500. Rate of depreciation is 5%. We have to find time period is 1 year. Okay. We have to find its final value. So final value we have to find. So what was final value? As per the formula, it is initial value into 1 minus, because there is a depreciation value, it's decreasing, to the power n. N is 1. Initial value was 10,500. 1 minus 5 upon 100 to the power 1, it is 10,500. It is again 19 upon 20. Clear? So it is 5 to 5, 38. So this is 997, 9,975 rupees at the end of 1 year. One more example. Example is, find the population of a city after 2 years, which is at present 12 lakh if the rate of increase is 4%. Okay. Present population or initial value, we can say present value, initial value, that is same. Initial population is 12 lakhs. It is increasing at 4%. Okay. Rate of increase. Rate of increase is 4% and time period we have been given 2 years. So final population will be, final population will be initial population into 1 plus, because it is increasing. Okay. 1 plus r upon 100 to the power n. N is 2 years in this case. Initial population is 12 lakhs. 1 plus r is 4. N is 2. So it will be, this is 25. This is 26. Okay. Now you can calculate its value. So this is how we have to calculate the things. Right. So we will be starting with the new exercise in our next video. Thank you.